Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. We've got these little giraffes, I guess, made out of blocks. Here's step 1, here's step 2, and here's step 3. Your challenge is to predict the number of blocks needed to make the giraffe in step 4. If you can do that, how many are needed in step 43? And can you write an equation that would predict the number of blocks needed in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. Okay, so obviously this is a shape that's built, in a three-dimensional way here, except I think it's only growing in one dimension, right? It only gets taller. It looks like the legs get longer and the neck gets longer. So let's see if we can figure out how much here. So there's that sort of 3 blocks for a head, 3 blocks for a body, and the legs start out as one tall. Yeah, it looks like we've added 1 each to the legs and 1 to the neck on that step. And let's see, yeah, I think we add 1 more each to the legs and yeah, just 1 more to the neck on that step. So if I were going to predict step 4, let's see, we'll have this 3 for the head, and then the neck should be 1, 2, now 3 long for the neck. And we've got that body that's 3, and then the legs are going to be 4 long. They were 3 long last time, now they'll be 4 long. So let's see if we can add all that up. Let's see, 4 and 3 and 3, that'd be 10 and 17, looks like, if I did the addition correctly. So that's what my prediction for step 4, 17 blocks. But let's actually make a chart so we can analyze these numbers. I'll put the step number here and the number of blocks here. I'm thinking this is a linear pattern, but let's verify that. So in step 1, we've got 3, 6, 7, 8 blocks. In step 2, looks like 11. In step 3, 14. And in step 4, we're predicting 17. And now when we take the difference between each step, 11 minus 8 is 3, 14 minus 11 is 3, 17 minus 14 is 3, we see that we get a constant there. So when the difference between the steps is the same, when it's a constant, then we know that the pattern is linear, and we can use that equation for a line to model it. So y equals mx plus b is the equation for a line that I'm going to use. And the m here, the slope in the line, is going to be this change from step to step. So in this case, that's 3. So y equals 3x. And we don't know what the b is yet, but we can figure it out from looking at the pattern. So if in step 1, I put in 1 for x, and we'll just use the equation as we have it so far. So y equals 3 times step 1. That would just add up to 3. But we've got 1, 2, 3, 4, 5, 6, 7, 8 blocks. So I'm 5 short. So to fix that, I'm going to add 5. And I'll add it over here as our b. Now let's take that equation and verify that it works with the other steps. So y equals 3 times, now here I'd put in 2 for this step number. 3 times 2 plus 5. So that'd be 6 plus 5 is 11. Yep, that checks out with step 2. Let's try step 3. Y equals 3 times 3 plus 5. And that'd be 9 plus 5. That'd be 14. Yeah, that's what we're getting in step 3. So it looks like y equals 3x plus 5 is a good equation. Seems to work for every step we've got. Once we've got that, we can plug 43 in for x to calculate the number of blocks in step 43. So y equals 3 times 43 plus 5. And 3 times 43, well, 3 times 40 is 120. 3 times 3 is 9, so 129 plus 5 is 134 blocks in step 43. Well, how did that go for you? Did you get 17 in step 4? Did you get 143? Sorry, 134 in step 43? Let me know. Thanks, everybody.